Hi class, welcome to your lecture starting chapter 4. Chapter 4 is going to be about triangles and congruence. We're going to move into section 4.1 first. So we have three objectives in this section. First thing we want to do is we want to learn the vocabulary of triangles. Then what we want to do is we want to classify triangles by their angles and their sides. And then the final thing we want to do is we want to find the angle measures of triangles. And then that'll be a little bit of algebra at the end. All right, so some definitions. So I've got this triangle here, and I've got these points here labeled A, B, and E. So a triangle is formed by three non-collinear points connected by segments. The non-collinear points are called vertices, right? The singular of that is a vertex. So the segments joining the points, like these things here, these segments here, are called the sides. So when we have this triangle, points A, B, and E are vertices. Point A is a vertex, that's the singular form. Point B is a vertex, and point E is a vertex of the triangle. We can write this as triangle ABE, like that. It can also be written other ways. You can call it triangle BAE or BEA. It doesn't matter. But whenever you see this notation here, that means a triangle. And then the segments, AB is a segment, BE is a segment, and BA are a segment. These are the sides of the triangle. All right, so identifying some parts. So let's given triangle PQR here. First thing I want to do is which angle is opposite segment PQ. So here's segment PQ. The angle opposite it is over here, so that's angle R. Which side is opposite angle Q? Well, here's angle Q. So the side opposite angle Q is the one directly opposite of it. Well, that's side PR. And then which side is included between angles P and angle R? So between this angle P and this angle R, well, that's obviously segment PR. Which angle is included between segments QR? So here's segment QR, and segment PR. So here's QR, and here's segment PR. So the angle between them is angle R right there. All right, so here's how you classify some different types of triangles by their angles and sides. So there's an acute triangle, and that's all three of the angles in the interior of the triangle are acute angles, so that's less than 90 degrees. You can have an obtuse triangle, all right? What that means is there's one obtuse angle, or an angle greater than 90 degrees. You can have an equal angular triangle, and that's all angles are equal, like this. They all have the same angles. You can have a right triangle that has one right angle like this. It can only be one right angle like that. You can have what's called a scalene triangle, and what that is no sides are of equal length. You can have an isosceles triangle, and that's at least two sides are equal. Like this, you would see the dash dash letting me know that these two sides are equal. And you can have an equilateral triangle. An equilateral triangle, all sides are equal. So you would get these double lines here letting me know that all the sides are equal. Or they could have one line through each of them, doesn't matter, just as long as they have the same marking. All right, so let's classify each of the triangles by its angle and its sides, and let's use specific names. So here I have a 90-degree angle, right? So that tells me it's a right triangle. I have no sides are equal, so that tells me it's a scalene triangle. So the complete name, or how we would call this, would be a right scalene triangle. So it's angle, sides, and then triangle at the end. Let's do another one. So I have something like this. So I have two angles are equal, I noticed that, and two sides are equal. All right, well, I noticed that all the angles are less than 90 degrees, so this would be an acute triangle. Because two sides are equal, like this side and this side are equal, that's an isosceles triangle. So the complete name here would be an acute isosceles triangle. All right, so some definitions. We call the three original angles of triangle the interior angles of the triangles. The angles that are adjacent to the interior angles are the exterior angles of a triangle. And you can see right down here, like, so I have this triangle embedded here. The interior are the the inside parts of the interior angles. The angles adjacent to the interior angle, so not opposite it, okay, but adjacent to it like this. So I have this interior angle, angles 4 and 5 are adjacent to it. Those are the exterior angles of a triangle, and there are two exterior angles associated with each interior angle. But since these two exterior angles are congruent vertical angles, like angles 4 and 5 have the same measure, 6 and 7, 8 and 9, all right, we usually only show one exterior angle with them, like this over here, all right, because there's no reason to extend this line here and then have another angle which is the same as 6. So exterior angles are only shown with one, even though there's two of them. All right, so we have the triangle sum theorem, and it turns out that the sum of the measures of the interior angles of a triangle is always 180 degrees. There's no other way you can do it. So if I have measure of angle 1 plus measure of angle 2 plus measure of angle 3 here, they will always be 180 degrees. Right? If they don't sum to 180 degrees, it's not a triangle. You can't do it. All right, so a corollary from this, or what is a corollary first? A corollary is a special name given to a theorem that is easy to prove as a direct result from another previously proved theorem. So if I have this triangle angle sum theorem, the first corollary I can have is what's called the exterior angle of a triangle. So this exterior angle here. So the measure of each exterior angle of a triangle equals the sum of the measures of its two non-adjacent, so not this one, interior angles. So these two angles here sum to the exterior angles value right here. All right, another corollary. This is acute angles of a right triangle. All right, two acute angles of a right triangle are complementary. So if this angle is 90 degrees and they must sum to 180, well, then it must be that angle 1 plus angle 2 is 90 degrees. All right, let's do an example. So use the triangle sum theorem here to find the measure of each angle of the given triangle. So I know that this angle is 5x, this angle is 6x, and this angle here is 15x plus 24. Well, I know that when I add all these angles together, they must be 180 degrees. That's what the triangle angle sum theory tells us. So combining like terms, this becomes 11 plus 15x is 26x. Subtract the 24 over, divide by 26, and you get x is equal to 6 here. Now that's not the final step here because it says find the measure of each angle. So what you have to then do once you know x is equal to 6, right, is use that value of x and the triangle to find the measures of each angle. So if x is equal to 6, well, for the 5x, I'm going to plug x into it, or 6 in for x. This is 30 degrees. If I plug 6 into here, 6 times 6 is 36 degrees. And then if I plug 6 into here, all right, 15 times 6 is 90 plus 24. This becomes an obtuse angle, or 114 degrees. All right, so if you check, we see very easily that these sum up to 180 degrees, and we're all set. All right, let's use another one. So use the exterior angle of a triangle corollary to find the measures of the exterior angle and the non-adjacent angles shown here. So the first thing I'm going to do, right, using that exterior angle corollary, this x plus 67 degrees has to be equal to 3x minus 53. So 3x minus 53 is equal to x plus 67. I'm going to subtract the x over. Sorry for the little typo here. That should be a 53. Now add 53 over. Get 2x is equal to 120 degrees. And x is equal to 60. So I know that that's a 60-degree angle right there. So let's use the value of x here and the given information to find the measure of each angle. So I know that that's 60 degrees. Plugging 60 into the measure of the exterior angle, I get 3x minus 53. Well, 3 times 60 is 180. Minus 53 is 127. So that exterior angle is 127. All right, we saw that that x is equal to 60. All right,